during the ascent of the magma, you can say by three process it can diversify. First thing, so parent magma can split into different composition. It can split into different composition, or you can say it can mix with other magma or magmas, you can say. It can mix with other one magma or more than one. Sometimes two magma can mix to form a different composition, or more than two also can mix. Then you can say broken fragment. They can fall. So if there is broken fragment from the wall, they can fall into the magma. So these processes, they can significantly change the composition of magma. Only this process, if it is sufficient enough, then it can change the composition of the magma, or it can give a new composition. So what are the different composition? What are the different process here? If it is splitting into two magma or two different composition, it is called as your differentiation. This can be called a differentiation if they are mixing with each other. You can say mixing of magma or tumbling of magma. And this process is called as your, the last one is called as your assimilation. Because some foreign matter or other matter from the water, they are assimilating within the magma. So for this process to occur, we need an important thing, that is your partial melting. This is a process which will generate magma. So what is partial melting? It is simple a process where some stones will melt partially. Because if you are talking about mantle or lithosphere, those are heterogeneous. They will not melt at a definite temperature. They always melt at a range of temperature. So at any temperature, the lithosphere or the mantle, it will melt partially. That is called partial melting. So that partial melted substance, time to time, it can separate from that place. So that when it will separate as a liquid phase, they can consider the composition. So with progressive partial melting, you can get different composition. तो लिथोस्फीयर अगर मेल्ट होगा तो जितना भी हमारा कंपोजिशन और जो भी कंपोजिशन होगा उसी हिसाब से इट विल प्रोड्यूस अ मैग्मा. So with gradual melting, it can produce different type of composition, because if something is melting, both melt and solid has a change in composition. Both melt and solid has a change in composition. So another thing, during partial melting, there are certain requirement or certain condition where the liquid phase within the solid will be move as an independent system, or simple can say the liquid can separate from the rest of the solid with certain condition. Not that some of the amount is melt and it will separate from the system. So what are the conditions that we'll discuss? So separation of liquid from the partial melted solid It is very important for the diversification. It is very important for the diversification of the magma. So when a rock begins to melt, it will melt from the grain boundary. From the grain boundary where 2 or 3 grains will meet. Like this. This is the grain boundary. So the melting will start from the grain boundary. Because of pressure or because of temperature, melting will always begin at the grain boundary. So the angle they are making at the grain boundary, that is called as a dihedral angle. The angle is called as a dihedral angle. What is written here 120, 180, 0 degree. So the melt will begin as liquid droplets. So they will attach with the grain surface here. They will attach with the grain surface. So what are the conditions required for the separation of the melted liquid from the solid? The 2 conditions should be fulfilled. One, the liquid must form an interconnected network through the grain boundary. It must form an interconnected liquid. That means suppose these are grain boundary like this. So if the melt will begin here, it will overflow to connect. So the liquid here will also overflow to connect here. Liquid here overflow to connect here. So the melt at the grain boundary should be sufficient enough so that they can form an interconnected network within the rock. They will form an interconnected network within the rock. Like you can see here, this is an interconnected network they are forming. Here it is not formed. In this case, it is not formed. In this case, it is forming a interconnected liquid. So this is the primary state where the melt at the grain boundary must flow or overflow or must connected with other melt in the grain boundary. So after that, as I was saying, these are liquid droplets. So they are attached to the grain boundary. So there is a attraction between them, what we call surface adsorption. Surface adsorption. So for the separation, the liquid must overcome that surface adsorption. Suppose ki this thing is like they are just you can say attached to the boundary like a like some glue. So that must be overcome. That must be overcome. So that depends upon the amount of liquid they are forming. The more the amount of they will form, the less the surface adsorption will be. Then they can easily separate from the system. So when they will able to separate from a system, they will form a melt which has a composition different than the solid. That the process is diversifying. So interconnected network formation depends upon the dihedral angle. Interconnected network formation depends upon the dihedral angle. If you have larger dihedral angle, that means suppose I'll say so when they will form an interconnected network, when this place is filled, this place is filled, then if they will overcome to connect with other liquid are in the grain boundary. If this place is larger means that the grain bound the angle is more. This place is larger means the angle is more. If this place is small, is the dihedral angle is less. So if we have a lesser dihedral angle, then we require a very less melt to form an interconnected network. If the angle is less, if the angle is less, then we will require less amount of melt to form an interconnected network. If the angle is more, then require more amount of melt to form an interconnected network. After forming an interconnected network, it will be overcome the surface atoms. So that's why diagonal angle. So that will determine how much melt is required to overcome or to form an isolated solid system, isolated liquid system or independent liquid system. So that amount of melt, that is called as a critical melt. How much melt is required to form an independent system, or how much melt is suitable to be separated from the solid. That depends upon dihedral angle, and the melt that is required, that is called as a critical melt. That is called as a critical melt. When that much or that amount of melt or that 1% of melt is reached, they can form an independent system and can move up or can ascend. That condition I told you in batch melting condition. So if the diameter angle is less than 60, the diameter angle is less than 60, only 1% melt is required whole from the whole rock. If the 1% of the rock is melt, then it is suitable for forming an independent system, or suitable for separation. If you increase the diagonal angle, then the connectivity also increase. If the connectivity will increase, that will increase the amount of critical melt required for the separation. Understood? So think we need a critical fraction of melt to form an independent system or to be able to separate from the solid. That depends upon how they are forming an interconnected network, how they are overcoming the surface atoms. That depends upon the dihedral angle, how they will, how much melt is required to form an interconnected network. If the place is larger, that means the dihedral angle is larger. Space between grain. So if space between grain is larger, dihedral angle is larger, we require more. We require more melt. Understood? Is this the condition, the sole condition that will form and separate melt? As we are saying, they will form an interconnected network. Another thing will come into play, that is mobility. So magma should be sufficiently mobile so that they can form an interconnected network. That means we have to consider the viscosity. The dihedral angle that is less than 60 degree, it will form 1% of melt. That is true for your mafic magma. That is true for only mafic magma, where the mobility is sufficient so that they can easily form an interconnected network. But what about viscosity? That in case of acidic condition, in case of rheology condition. So in case of rheology condition, they will not form a melt, or they will not form an independent system in 1% of melt. They require much higher percentage of melt to form an interconnected network because of their higher viscosity. They are not mobile. So in case of acidic, you require 25% of melt, or as less as you require 15% of melt. It doesn't depend upon the dihedral angle. The more the dihedral angle, the more it will require the melt to form an interconnected network, because it depends upon the mobility. That mobility is not found in case of acidic condition, which is less mobile. So viscosity. So the critical melt fraction for acidic magma, that is what we called rheological critical melt percentage, it is around 25%, and for some other scientists or other geologists, it is from 15 to 17%. So because high viscosity means there is no mobility, so you require more force. So that's why they will form a melt dominated fluid, which has a crystal mass. So they be within the system for more than 25% or 30% of melt, where there will be a condition solid will suspend or be like a very viscous or denser condition they will form. So that's why during acidic condition you require higher percentage of melt to be separate from the system. That is up to 25% or 15 to 17%. So after formation of the melt, they will move as the independent system. They will ascend. So during their ascent, they will diversify. So there are three types of diversification process. One is your differentiation, then magma mixing and assimilation. First we say differentiation. So this is the process by which magma can split into two composition. The magma theta composition split happen. So differentiation also can be between solids, liquid, can be between liquid and liquid phase. So for differentiation process, we also need two essential process. First, the process should form a compositional difference between two differentiated things. Suppose the two things are differentiating from each other, they should have a contrasting composition. They should have a contrasting composition. You suppose solid is melting, so the melt will form, it has a different composition than the solid. So then the melt, when it will separate, it will have a different magma. Or if you have a melt, the melt contain different composition, so that they will be able to separate. Can take the example of a liquid immiscibility, where we have a liquid at certain temperature, they will separate from each other. At certain temperature or a higher temperature, they are mixable, but at lower temperature, they will separate as different phases. X solution. X solution mana chha nahi? The liquids are mixable at higher temperature, but when the temperature falls, they will move as independent system or they will separate from each other, like oil and water. So first, you have to create a compositional difference. You have to create a compositional difference between one or more phases, because it can involve a liquid phase only, or it can involve liquid or solid phase. So that depends upon pressure, temperature, composition. Obviously, if at what temperature the solid is, according to that it will melt. What is the composition also depends whether it will melt or not at that temperature. So all these factors that affect the melting, or you can say separation. Liquid को था वाला कि at higher temperature they are mixable, low temperature they are unmixable. So that depends upon obviously pressure, temperature, composition. Then preservation. That means कि when you are creating a compositional difference, that some process, there should be some process that able to separate that liquid from the solid, or that able to separate those two contrasting composition. Those processes you have studied in differentiation, like your the fractional crystallization, like your volatile transport, like your filter pressing. Those are the process they help to preserve this composition difference. Once we have two contrasting composition, that should some process they will be preserving these two things. নহলে କ'ଣ ହବ? If conditions will be there, they can again assimilate, they can again recrystallize, all other things will happen. So that the contrasting composition will not be forever, you can say, or would not be longer enough to exist. So preservation of chemical difference between created segregation. So fractionation is a physical process. So what we will study here. So what are the different differentiation process? One is a fractionation. There is a fractional crystallization. Fractional crystallization means the removal of early form crystal. So that is a fractional crystallization. When early form crystal is removed from the system, then the melt will modify. The melt will modify. Suppose ki we have taken the dioxide 80, anorthite 20. Initial liquid. So when it will start to crystallize, its composition will modify. Suppose here dioxide 60, anorthite 20. Now this composition is different from the earlier composition. So If any process this liquid can separate, or in any process the solid can separate, then we'll get isolated dioxide 60 anthracite 20, which will give you another composition of liquid. That is your diversification. So fractional crystallization can produce different composition of the liquid at different stage of crystallization. So how it will, what are the process? That is your gravitative settling, filter pressing, or flow separation. That means कि those liquid they can separate, or those solid they can separate by gravitative settling, they can separate by filter pressing, they can separate by flow separation. That's how they preserve the compositional difference. This gravitative settling, filter pressing, flow separation. That's how they will preserve the compositional difference or contrasting composition. Gravitative settling we all know because that is only depend upon the density. Where the high denser mineral will settle to the bottom of the magma shower, and the lighter will be at the top. That is the layering, or that is the separation that purely depend upon the density. So that's why it is a basic commonest fractionation where more high denser crystal will settle to the bottom and low denser mineral will be on the top. So they can be form a cumulates. So come cumulates texture formation. Because they are floating on the magma or they are settled to the bottom of the magma. Those are called cumulates. And this process is also helps to produce layering in the igneous rock. Layered gabbro, you find that it's a flow condition. Layered gabbro, they are all produced by this process, gravitative settling, where the then denser mineral will be more darker, the lighter mineral will be lighter color. So that's why they will form a contrasting color layering. So it can be seen in gabbro. So it is your gravitative settling. Then comes to filter pressing. Filter pressing is a phenomenon. Suppose you take a foam and then soak it in water, then squeeze it. What will happen? Water will expel. So water variable. So similar process filter pressing. Suppose we have a condition where solid and magma is there. So solid is floating on the magma. So if you have pressurized that condition, if you pressurize the magma in that condition, then the liquid will separate from the solid. That's why the name is given. Filter pressing. So you have to filter the liquid by applying pressure. By applying pressure. You suppose that can be occur in this condition where the magma is flowing through a narrow conduct. Magma is flowing through a narrow conduct where the crystal cannot pass. So only the liquid can pass. So here the pressure is increasing in this condition. In this part the pressure is increasing. So only the liquid can pass. So when all the liquid will pass, you will get only the solid. But that is filtering the liquid from the solid due to increasing pressure. That is why the filter pressing. Filter pressing is the cause of formation of many monomineralic rock. Where the early from crystal, there is only one type of mineral is there. Suppose you consider during the early stage crystallization of the plagioclase, albeit anothrite. And first will produce more anesthetic member. So in that case, if it will, if all the liquid are separate by filter pressing process, you can get another side. In case of dioxide anosite also, if all the key dioxides are fast formed up to the eutectic point, if in that condition all the liquid can be separated, it can form a pyroxenate. It can form a pyroxenate. This is a filter pressing, where solid and liquid are separated when pressure is applied. देखो flow segregation. So flow segregation when magma reach with crystal. Magma reach with crystal when it will flow through a conduit or through a pipe. So what will happen? Suppose when magma they will have a very rich crystal percentage, then it will be more viscous, more denser. So when it will flow through a pipe, so the wall of the pipe or wall of the container or fissure, you can say fracture. Wall of the fracture is stationary. Wall of the fracture is stationary. So when it will pass through the wall and the magma, they will have a shearing condition. They will have a shearing condition. Shearing condition of anything. So when magma will flow, the wall part it will have a lesser velocity than the central part. The wall part will be has a lesser velocity than the central part. Then magma will contain more larger crystal. Magma will contain more larger crystal. Suppose see here when it is flowing through here or through here, space will decrease according to this area where it is flowing. Here the space will decrease. Here the space will decrease. So if the space will decrease, pressurized here. You know, pressurized, and it will exert pressure on both sides. It will exert pressure on both sides. Both side pressure exert. The wall is stationary. The wall is stationary. In this phenocryst or larger grain, it will move towards the center. It will move towards the center because this is also another grain. They were also forming a smaller area here. So liquid will constrain here at higher force. It will push it towards the center, and here it is pushing okay, the phenocryst towards the center. So because if this will move, when this will move, it will create space. So that's why this pressure will not be effective because when the liquid is passing through this point, it is experiencing pressure on both sides. So uh, on this side there will be no pressure because the pressure will not push the container because it is stationary. Only the crystal or solid that present within the flow, they will be moved. So when magma traveling with this constrained area, with this smaller area, it will exert a pressure that is called as a grain dispersive pressure. Grain dispersive. Similar thing also happen on the other side of the wall. Similar thing also happen in the other side of the wall. So by this process, all the crystal part, so the larger part, they will be concentrated at the center. They will be concentrated at the center because larger grain will experience more dispersive pressure. Larger grain will experience more dispersive pressure than smaller grain. So they will concentrated at the center of the crystal. Sorry, center of the flow. That is also a condition of separation of the solid from the liquid when all the solid will concentrated at the center. This is because of dispersive pressure. So when magma that moves through this narrow conduct in between crystals, they will exert a pressure on the phenocrystal or on the crystal. So because of this pressure, it will push the crystal into the center. Why it will push the crystal into the center? Because the wall is stationary. Right? Wall is stationary, and the grain dispersive pressure is directly proportional to the grain size. It is directly proportional to the grain size. The larger the grain, it will be at the center more, and from the center to towards the wall, you will get closer to final. That is also a condition where all the crystals are accumulating or segregating at the center. And this segregation is occur because of the flow. So that's why it is called as a flow segregation. Then comes to volatile transport. These are the processes that come under fractional crystallization or fractionation. Volatile, sorry, gravitative settling, then filter pressing and flow separation. They ought to help to preserve that composition during fractionation. Then volatile transport, obviously volatile is a very lighter metal. It always move up. So when separate for a vapor phase that release from the coexisting magma and move as an independent system. So it can be deposited over other host rock where it can form an individual deposition or it can affect other type of rock or help in case of metasomatism. So vapor phase has a lower density. When it will be released from the magma, it will easily separate. That is the thing. There is no proper other mechanism is there. So when they will separate and they can deposit other rock, the example some is your alkali metasomatism known as ferritization, where the fluid nepheline carbonate bodies are attributed to alkali rich fluids derived from highly alkaline intrusive. So from highly alkaline intrusive magma, the alkali rich fluid they will separate and will deposit it on a nepheline carbonated bodies. They will form penitite, penitization process. Also, tomorrow the fluid also helps in very other process of added black smoker, white smoker, VMS deposition, all because of volatile transfer. VMS is also considered as liquid immiscibility condition. VMS is called liquid immiscibility because it is sulfide gas separate from the silicate. Next, of liquid immiscibility. There are some liquid they cannot mix with each other at a particular temperature pressure condition. They will separate or they will differentiate from each other as separate phases. So you can take the example of oil and water. Also, your albrite and K feldspar or orthoclase. They are mixable at higher temperature, but they will form separate solid at lower temperature. Just like alkali feldspar immiscibility system, that is depend upon the temperature. But called X solution. Oh, X solution. There are other example also. Just remember this example: liquid immiscibility. Main in case of silicate sulfide, they are separate. They are always unmixable at low temperature. Where silicate and sulfide they will separate from each other to form different types of economic deposition. For example, VMS and carbonate alkali, they all will separate from each other at certain temperature pressure. They all like oil water, they are not always mix. They are not always separate from each other. They will they are before at higher temperature at certain temperature they will form a mixed phase. But when the temperature comes, they can separate from each other. So they all are on temperature dependent. So these are the example. For example, from one This is all about more differentiation. Fractionation, the volatile transport, then liquid emission. So next come to another process, that is your magma mixing. The mixing of two magma. Very simple. You can understand this on the context of your solid solution. So where different composition they can mix with each other to produce different type of rock. Okay, albite and oxide, they are producing a range of composition between them, or phosphate pyrite. Similarly, if two magma they will meet, that is your coupling, mixing gas, that is coupling. So they will form a composition in between the two end members of the magma. Like suppose ki, you can say albite and anorthite, they are mixing, they will produce a composition in between them, where some amount of albite is there, some amount of anorthite is there. So in this process, we can produce a variety of magma. But magma mixing thing is only not confined to only two magma. You can, if magma can mix with more than two or three magma. More than two or three magma, they can also mix with each other. It is very common process in volcanic magma chamber, so which is a very kind of open system. Because for magma mixing, we require a kind of open system where other magma from the neighboring place they can access the magma chamber. So if it is a closed system, then other magma cannot mix with the existing magma. So magma mixing always require a open system. So it is also more a form at the deeper level of the crust, where there is such sufficient more permeability or more volatile flux. For example, you can say in case of underplate condition. Underplate condition, what is the underplate condition? In case of converted plate boundary, or in case of hotspot region. So where magma will produce or mantle plume will rise. In case of hotspot, mantle plume will rise and it has rest beneath the crust or lithosphere. Then in case of convergent plate boundary also, the subductive plate it will melt and the magma will rise. When the magma will rise, then it will rest below the lithosphere, and because of the heat, the lithosphere or the crustal part will start to melt. The crustal part will start to melt, and that will produce a magma, which is acidic. Now this is basic. They will mix with each other. They will produce an intermediate composition between them, which we get andesitic magma. That is the whole process of magma mixing. Another thing about chemical depletion is also an important thing, where the chemical concentration or chemical gradient will create other magma can mix with each other, or you can say the magma will recharge in somewhere where other magma will mix with the depleted magma. So those are the conditions where magma will mix with each other and produce a new composition. Example also you can take more basaltic and intermediate or silicic liquid. So there is a greater compositional difference. They will produce layering, lighter and darker color layer. Or they also sometimes produce mixing of magma if there is a greater compositional difference. Then suppose ki there is basic and silicic. So that means ki basic magma is more denser, hmm? less denser, less denser. They can mobile, they can be easily mobile, but the acidic magma they are less denser, they cannot mobile. So that's why they will form like patches within the basaltic magma. They will like this. They will form enclosed space like this. When there is a greater viscosity difference. One second. So assimilation it is a process where When magma will ride or ascend uh, material from the surrounding contour, foreign material, they will fall within the magma, and if significant amount will fall or it can assimilate significant amount, it can change the composition. Assimilation always doesn't change the composition of the magma, but it can change with time. So that's why it is in diversity process. It is a process where it can dissolve or it can absorb a contour rock or it can react with a contour rock. So like this you can say, when magma is moving through the fracture of the contour rock, it will assimilate the contour rock like this. Suppose ki in this place magma is completely dissolve all the contour rock, but those constituent which is higher temperature than the magma, they will remain as undigested material. That is called as your genolith. That is called as your genolith, which is cannot be digested by the magma or cannot be melted by the magma. They will remain as genolith. Example, you can take diamond. Diamond is a genolith within the magma. So as magma passes upward, the pieces of cross contour that will fall broken up will be assimilated by the magma. So the process लिखा है. So what are the condition? What are the requirements? एवरा देखिए. तो जो condition रे तुम्हारे the magma cannot digest those things. Those are called कौन? Genoliths. Genoliths are also bring information about the deeper mantle. So assimilation process that include heat up solution, then heat up melt, and heat up mixing. That means ki how much it will assimilate, what composition it will assimilate, obviously depend upon the temperature of the magma. What is the temperature of the magma? According to that, it will assimilate or it will mix other solid. So what is the heat of solution? It is the ability of the magma to dissolve an inclusion. That depends upon temperature. Heat of melting is the heat capacity. That means ki suppose ki if you are placing a hotter material to a colder one, then heat will transfer. But if you place it for a longer time, then the colder material temperature will gradually rise. That is your heat capacity. So it is the heat capacity of the solid phases, that how much temperature it can raise. Then heat mixing is the heat required to mix the phase. Always you can take the example of amul. Amul will not mix in a colder phase or colder water. It will always require hot water. So all different type of composition require different temperature to be mixed within the magma. So it consists of three processes. First, melting of the wall rock. Either it will completely melt the wall rock, the dissolution and diffusion of wall rock within it. It will dissolute and diffuse the wall rock within it. Then, if the magma is or the wall rock is reactive or the magma is reactive, they will react with each other. They can do a replacement reaction. They can do a replacement reaction where the constituent in the fluid they will deposit on the wall rock, and constituent in the wall rock will deposit in the fluid. That's how the composition of the wall rock and the fluid both will change. So melting required obviously temperature. So it obviously depend upon the temperature of the magma. If it is a basic magma, then it can easily melt a acidic rock, sedimentary rock, or all that rock. If it is acidic magma, it cannot have the capacity to melt a basic or basaltic rock. So it will bring if acidic rock will come in contact with a basic rock, then what will happen? The from the acidic magma, the volatile constituent will enter into the basic rock, and all the dehydrated mineral within the basic rock they will convert to hydrated mineral. that will happen. That is the reaction will happen. The reaction will happen, alteration will happen. So melting requires two essential components because when something is melting, that depends upon who is melting and in which it is melting. So both the constituents temperature are necessary. Suppose ki wall rock has a melting temperature and the liquid has a temperature. So if liquid can provide that much of temperature, then the water can dissolve or melt. So it is a necessary or heat energy necessary to raise the temperature of the wall rock to melting. So when the magma is in contact with the wall rock for longer period, then it can raise the temperature of the wall rock so that they can melt. And the latent heat, the heat that formed by the reaction, exothermic reaction, heat that must remain or added to the system. Because if they will add it to the system, they can also increase the temperature more. Because when the wall rock is melting, means it is forming or it is having a reaction with the magma. So when it is forming a reaction with the magma, then it will release temperature. That is called as a latent heat. So that heat must be kept there. If it will be not there, then the further temperature will not raise. Another thing, if more magma will crystallize, then also temperature will increase during freezing condition because of heat of crystallization. Because of heat of crystallization. So magma must be superheated to provide substantial amount of heat without freezing, or large quantity of magma freeze to provide enough heat. Superheated means magma will raise its temperature to a level where it will be solid but will not melt. That is a superheated condition, means it is beyond its melting temperature but still it is in solid condition. There is superheated condition, opposite of supercooling. So there are some certain condition magma should be superheated so that it can raise the temperature to a certain level so that other metal can melt. Otherwise, large quantity of magma, when they will freeze, they will produce heat of crystallization. They will produce heat of crystallization that also helps for melting. So that's why only hotter magma can assimilate cooler magma. So these are different more of criteria or condition you can put for assimilation. Then diffusion in solid state, heat can diffuse very at slow rate because rocks are very poor conductor of electricity. That's why dissolution required. Then fluid can react with the country rock or wall rock, so they can exchange ion with them. They can replace each other's ion. So for the ion exchange between the magma and wall rock, it is favored a chemical potential gradient in contact zone reaction that is governed by the type of alteration that is actually proceed, wall rock composition and pressure temperature. Because all these replacement in any condition they will depend upon these conditions. So जगह पे alteration होची तो all will depend upon this condition. One होची कि what are the type of alteration that is proceed and what are the constituents that are involved, whether they are reactive or not. If they are reactive, they can replace each other position. So the water composition and liquid composition is important for the replacement. And all replacement always occur at a particular pressure, temperature, and environment condition. So a particular pressure, temperature, or environment condition they produce. So in this process, the composition of magma can change from the wall. Already replacement case. In case of replacement. These are some example. Example আছে পড়িব. So once basaltic magma, when it is assimilating a granitic solid, the basaltic magma it is intruding a granitic region. Then obviously basalt has got higher temperature than granite. That is say it has got quartz, feldspar, the biotite, alkyl feldspar. So they all will be melted. All will be melted. That is in case of तुम्हारा when granitic magma, that will include a basic magma. That is because of the granitic magma or acidic magma has lower temperature, basic magma has higher temperature. So only the volatile will add to the basic magma. When the olivine, pyroxene, plagioclase, they will be altered to mica, amphibole, and epidol. And also the heat of crystallization of quartz, feldspar, biotite from a granitic liquid is not large enough to melt a basaltic magma. And if anything that include into a sedimentary terrain, then all will melt. Sedimentary terrain can easily melt. And if it will any acidic or basic magma, when they will intrude into a limestone region. When it will intrude a limestone region, they will produce special type of rock that is called as scar. The more acidic or basic magma, they will intrude into the limestone. These are the examples. These are different process of assimilation. The X which initial composition, E eutectic composition, Z which where our liquid is. Initially we have taken 150 gram of 150 gram of liquid. So at Z point you have to calculate how grams of dioxide crystal is there, how many grams of dioxide melt, how many grams of anorthite melt. Z. So this segment will give this segment's compositional difference. It will give solid. This will give liquid. This is your 85 minus 78. How much? 7 solid segment. Liquid segment is 15. So 7 by 22 into 100. How much? 31.81 or 32%. Example calculate no bunny. 7 by 22 is 32% suppose. Then 15 by 22 it is 68. So solid is 68%, liquid is liquid is 68%, solid is. So I have to take 32% of 150 gram. Initially we have taken 150 gram. So 150 gram to 85% dioxide actually our liquid anorthite is 50%. Anorthite to किसी भी crystallize करूँगा. No करूँ, but melt रहियो ना, पढ़ाओ कोने. अगर 150 gram रो, obviously 150 gram of melt. They are crystallized. Part of the melt is crystallized. Now at Z point we have a bulk composition of both solid and liquid. So that solid portion is 68%. What we have liquid portion is 68% and solid portion is 32%. What we have taken initially. So that is 150 gram. So 150 gram ra 32%. 32% of 150 gram is your dioxide solid. Okay. 32% of 150 gram. So 150. How much? 48 suppose. This is the dioxide crystal. Then melt. 150 minus 48. Suppose 102. Melt is 102 gram. From which, from 102 gram. So 78% of 102, 78% of 102 gram of melt is dioxide. 22% of 102 gram is anorthite. So you have to calculate 102 into 0.78. How much? 79.80%. If it is 80%, then it will be 20. Because you have not considered the decimal, so that's why it should be 22 actually. Perfectly 22. As we are not considering the decimal, so that's why little less. So this is our initial composition y equal to dioxide 17, anorthite 22 is in solid field. So suppose it is melting. So you have to calculate how many moles of dioxide melt will form at 1274 degrees centigrade if you have initially taken the solid as 5%. So suppose this is your point where we are asking the liquid percentage. This is your solid. Sorry, you have to calculate liquid and solid percentage here. What is the liquid percentage? What is solid percentage? What is the liquid percentage? What is the solid percentage here? Liquid 52.38, solid 47.61. These are percentage. Then in gram 260 gram liquid. So from 260 gram, 15% is your, from 260 gram liquid, 58% is dioxide. 260 into 0.58. How much? 5.8. So from the liquid that is forming at 1274 degree, from the liquid 58% is dioxide and 42% is anorthite. The whole liquid is not dioxide.
Eutectic जो 500 ग्राम अच्छी तादरे 22 ग्राम जो 22% जो अच्छी अनऑक्टेड तो 22% वाले 111 ग्राम 110 ग्राम so 110 ग्राम जो अनऑक्टेड अच्छी that 110 ग्राम is equal to 42% of अनऑक्टेड
that 110 ग्राम अच्छे थोड़ा एतु धंदा करनी सिंपल जिंस कहूची तुम सॉलिड लिक्विड बाहर करबा वाला एते लेंथी प्रोसेस में कोड फॉल्टी अब सिंपल थिंग कहूची कि व्हेन लिक्विड रीचेस दिस मच होची कि इट विल फॉर्म सम सॉलिड एंड लिक्विड सॉलिड it contain 100% of dioxide and liquid it contain eutectic composition of the liquid. So just calculate the liquid percentage and solid percentage. Liquid percentage, solid percentage calculate करें. So from the liquid 58% is unaffected. This is the complete process जो तरीके no error है ना. यदि other process use करछो तो it will be difficult. यदि ये प्रोसेस से तुम्हारा जहाँ बात है तुम्हारा सेम प्रोसेस बाहर है तो तुम्हारा प्रोसेस रॉन्ग. 0.58 basically 58% unaffected. Same process 150.8. So it will be 0. How many moles? 262 grams of liquid. 260 gram of liquid or 262 gram? 260 क्या हुआ? 151 तो ठीक से बाहर कराएंगे. What is the liquid percentage? 261.9. 261.9. ताकि तो बोलो 260. 262 gram. So what then 262 gram of 0.58% माने liquid is 262 gram from which 58% is your other side, so it will be 1 then mole 0.701 moles. The answer.